So what we'll do is when I click on that button, I'll set the number of devices equal to T-Capture Device Manager, current, and then get the count. So of the current device manager that I have, get the count of the number of devices, and then we'll set a label to be the number of those devices. And then we'll iterate through the number of devices to display. So here's, I'll get device manager, current devices indexed by I, get the name. I'll also get the media type, is it audio or video? And also get the state of the current device, whether it's of the audio or video device. So that's pretty straightforward. You can iterate and see, and you might have multiple audio devices. So let's just run this one on Windows first and see what we've got for devices. And here's the devices. It turns out there's just a microphone, plug-in microphone that's available on Windows. But let's go to the Macintosh and we'll run this example. There it comes. It's over here. We'll call get devices. And this actually finds multiple devices. There they are. So it's got, let's see, 4 different audio devices. Sunflower 2 and 16 channel I've got installed. The built-in input, which is built into the case, and a microphone input. And here's the camera, this built-in eyesight. You can get all the devices and then decide in your application which devices, audio and video, you want to use. Let's run this now on the Samsung Slate, and we'll see that it's got 2 cameras. So let's just click on Get Device. And so it's got a couple microphones, inputs, line input, and it's got 2 cameras, an SC, and it's got these big numbers. It doesn't say forward and backward facing or front facing or rear. It's just got the 2 of them here. And again, audio types and video types. Things that are new inside of FireMonkey is we've got support for audio and video. So let's bring up this media player example. New in FireMonkey 2, there's a media player component, T Media Player, and you give it a file name, and a media player control, which is where the video will play. We can place that and align it to the client area or not. You just run this example, and we can go and load a file. So let's go to turtles in Barbados. And so this is some video I shot in April of us snorkeling and feeding the turtles. And you can use this track bar at the bottom to skip around. All right, let's look at the code underneath. So first thing we do is when we click the open button, we set the open dialog filter to be equal to the media codec manager as the class, and get the filter string. And so if you want to know if you want your filter set to all the different file types for audio and video that FireMonkey supports, just call get filter string, and it'll give you the concatenation of all the supported file types. Or you can put into your own open file dialog filter just the extensions and names of the media types that you want to open in your own application. So if we say open dialog filter is the codec manager's filters, then if we choose a file, then we'll set the media player file name equal to the name that came from the open dialog. And then we'll test to see if it actually is a media file, because we want to make sure that that's actually a media file. And if it is a media file, then we can access all sorts of information in the media player. For example, we can get the video size, we can get the duration, we can get the volume, and we can use that to set, for example, in this case, we're going to set the maximum value of the track bar equal to the duration of the video, so that that track bar will track along as we play through the movie or play through the audio clip. We'll set the volume track. There's a little, let's see, vertical track bar for the volume, and we'll set that equal to the volume of the original clip. And then we'll just say media player, start playing the video. On the toolbar, there's a speed button. We can click on a button, and it just toggles between play and pause. So we just tell media player stop. Stop does not mean stop and rewind. It means stop at the current point and leave it there. So we can toggle that back and forth and tell it to stop and play and stop and play. You can also get at the state of the media player, so see what its state is, and if its state is that it's playing, then stop it, and if it's paused, then play it. Down here we've got a timer, and the timer is just taking the current time and it's setting the trackbar value. So the trackbar will move as the video plays move along. Now, if we change the trackbar, notice I did that, I dragged along, then we'll just set the current time to the value that comes from the trackbar. Remember, it's set from 0 to the maximum or the duration of the video. And we can also use this other trackbar that changes the volume. You can move to a certain point, just set the current time to any specific point, and then start playing from there. This works on Windows. It also works on Macintosh. So let's run it over here. And again, this media player works in C++ or in Delphi. So here we go. We've got a video somewhere here, probably that same Turtles. Let's go and find it. Here's the Turtles. Macintosh loads the file, so there's the Turtles. Notice we have a Macintosh look and feel now. There's those nice Turtles. Now this is all done inside of the media unit. Here's the FMX media, and then this defines the top level, the device state, the buffer ready events, the media type, audio and video, and then inside of the same subdirectory, there's also units for specifically Windows and Macintosh. Here's Media Win and Media Mac. So let's open up this one, and let's also open up the Macintosh version. So these are the implementations, a lot of implementation details. Here's the interfaces, and then the rest of it. Down at the bottom in the initialization section is where we register the media codec class using the codec manager for the ones that FireMonkey knows about by default. So AVI, WMV, MP4, M4V, MOV, and then for audio, WMA, MP3, and WAV. You can use the same, if you have some other file formats that you'd like to support, you can use this same code, the register media codec class in your own code, and provide the extension name. The media type, is it video or audio? And the same thing on Macintosh. If we scroll down, this is all the implementation code. So if you have professional through architect editions, you get all the source code to FireMonkey, VCL, and everything else. So down here on the Macintosh, we have support built in for MOV, M4V, MP4, and AVI, and then WAV and MP3 files. We could capture audio. In this simple application, you can capture audio streams, and you can capture bitmaps of video. So here's T audio capture devices, the class coming in FMX media, and I'll set that to the variable my audio. So I'll say my audio equals T capture device manager. We'll take the current manager, and in this case, I'll just say the default audio capture device. And now I've got my audio capture. And I'll say if it finds that capture device, then we'll set the file name equal to something, and we'll start capture, and we'll keep going. If it couldn't find an audio device to capture audio, then it'll say it's not available. Then we'll keep going till we hit stop capture. Now we also have a video capture example that comes with XE3. And so it's the same idea. Underneath here, we'll define a video camera as a T video capture device. And then down inside on the form create, we'll say video camera equals T capture device manager, current, and then default video capture. And if we find a video capture device, then we'll simply set the event handler for on sample buffer ready. In the case of the capture, it captures a frame at a time. So we'll set a procedure in that event handler for when the bitmap is ready in the buffer, and then we'll call video camera start capture. And then down below, we'll simply say when the video camera has a bitmap, we'll take that sample buffer to bitmap and store it into the image of the bitmap that'll be on the user interface. And we'll keep doing that until we tell it to stop capturing. We can see if the video state is that it's capturing. If it's capturing, then we're okay, and we can stop it or start it, and we can even save the bitmap. So in this case, I'll run this on the Macintosh because I'm running a VM here, and I've got the camera associated with the Macintosh. We'll have that application come up, and there's me. Hey everyone, this is David I. So here's the frames coming in, one frame at a time that's coming in. Anders took the original video capture example, and he modified it to support new capability in FireMonkey, and the capability is a new component called texture material source. And the texture material source has a property which is a texture, which is a bitmap. If you remember in FireMonkey 1, if you looked at it, when you had spheres and other 3D objects, is you could put a bitmap right on top of them. Now you can decouple the texture from the different 3D controls and associate the texture with a 3D control. And then that 3D control, for example, like in this viewport 3D inside of a 2D or HD FireMonkey application, we have a sphere. And that sphere now has a material source, a new property, and I've associated that with my texture material source. Anders also, in this example, has a layer, and inside that layer, he's got an image. And so the image that will display. And if we look at the code underneath, video camera is a capture device manager, the current default video capture. And then notice the next line, which is commented out, video camera, T-Capture device manager, current, get devices by media type. You can also filter and get all the devices. And what type? The type that we want is T-media type.video. And since this has two cameras, we can either use the first element or second element of the device array, and we'll cast that as a T-Capture device. So the default capture device on the Samsung Slate is the camera that faces out the back of the slate, and then the one or second element in the array will be the built-in camera. And then we set the procedure for the sample buffer ready when it grabs a bitmap. And then down at the bottom here, we will we'll take that bitmap and put it into the image, which is on the layer in the 3D viewport. So it's an image sort of angled away from us. And also we'll set the texture, the same bitmap, as a texture material source in the texture property, which will then texture it onto the sphere. View out the back of the slate. So now this is the studio that we're in. There's the clock on the wall. There's Anders over there. Okay, that's using the camera out the back. Let's go back to that line of code, and let's use the forward-facing camera. So here I am. And that's the forward-facing camera. So you've got the support for multiple cameras just by using the device array. And again, you can get devices by a filter type, by the media type, audio, video, and so on. A few other things that we've added to FireMonkey. We've got support for some sensors if they're available on your hardware. The Samsung Slate comes with an accelerometer, and Windows 8 and Windows 7 have a location sensor API. And so let's load up this example. What it does is it's got a location sensor component that is available to be used if you have that running as a sensor on your platform. We're going to use that to store the latitude and longitude. So as the location change, data change, we'll just take and set the latitude and longitude to the two edit boxes. And then if we click on the button, we're going to just do a shell exec to take this URL to Google Maps and display where we are on the planet Earth. So let's run this example. The location sensor, T-location sensor, is available in XE3, so we'll activate it. There's our longitude and latitude. Let's show the location. And it hopefully will get us to where we are right here in beautiful Scotts Valley, California, right near Highway 17, about 6 to 8 miles away from the Pacific Ocean. The other thing this Samsung Slate has is it's got an accelerometer built in. And this Samsung Slate 7 originally came with Windows 7 Pro, with some Samsung drivers put in. And what I did is I blew the solid-state disk away that's in this little thin device. We have the motion sensor, and the motion sensor just can be activated or not. And we've done motion sensor data change. We'll take the sensor, and we'll take the acceleration, the X, Y, and Z axis. And then we also have the angular acceleration, the motion and speed of the motion sensor. So in FireMonkey 2, abstracted out the devices. We've also abstracted out the sensors. So there's these sensors that you can get access to. Again, if your device has this, some of this is also paving the way for as we get to mobile devices, which come with GPSs, accelerometers, compass, all these kinds of things. And so it's already built into FireMonkey 2. Let's run this example on this slate, and notice that it's displaying the X, Y, and Z, and I'll move it around and I've got it in a kind of a docking station, but I can still move it around. And that's the first column. The second column is that angular axis, and the button here is just going to display the information about the sensor, and it says that it's an ST Microelectronics 3-axis accelerometer. The Windows 8 accelerometer, the driver that we have, is only 3-axis right now, but when Samsung gives us a 6-axis accelerometer, right, then we'll get the rest of those columns filled in. NAN is actually a number. It's a floating point, not a number. These are components that are available for your FireMonkey applications, and they'll work if the underlying operating system supports them and the hardware supports them.
In RAD Studio XE3, we now support gestures in your FireMonkey Windows and Macintosh applications. So let me show you how easy it is to add gestures to your applications. We'll say File, New, FireMonkey application for Delphi. We'll create an HD FireMonkey application, and we'll put a panel down, and we'll use that panel to make our gestures. And then we'll put a label, and in the label we'll display what gestures are found as we're using them. We'll also add a gesture manager, and now when we select the panel, we can go down in the object inspector and connect using the touch property. We can connect the gesture manager to the panel. And underneath that we have all the standard gestures, so we can just check whatever gestures we want to use. And then on the Events tab, there's an On Gesture event for the panel. So as we make gestures in the panel, we'll get information about the gesture, and we can use it in our application. Inside the On Gesture event, we'll declare a variable, which is of type string. We'll use a new built-in function called Gesture to Ident, which is part of the FireMonkey support for gestures. It takes the gesture ID from the event info and returns it as a string, and then we can put in the label what gesture we made as the name of the gesture. So let's run this application. And now we make gestures inside for the gestures that are enabled: circle, chevron, chevron right, up, down, and so on. So that's how easy it is to add gestures to a Delphi application. Let's do the same thing in a FireMonkey C++ application. So we'll say FireMonkey Desktop C++ HD FireMonkey application. We'll put a panel down, and we'll put a gesture manager, and then inside the panel we'll connect up the gesture manager, and then we'll just choose a few gestures that we want. And then we'll put a label down, and that's where we'll display what gesture that we made in the panel. And in the panel, the On Gesture event for C++, we'll put some code. This code we'll call Gesture to Ident, pass the event info gesture ID, we'll get the string, and then we'll just store into the label the name of the gesture that we made. And now when we make our gestures, left, right, up, down, if we make a gesture that's not enabled in the gesture manager, the event handler will get SGI, no gesture. But if it's one that we've selected to handle, then we get the right identifier. Now let's run this FireMonkey gesture application on Macintosh just to show that it also works for Windows and Mac. Here we have the application, and on the Macintosh we need to use a touchpad or trackpad on Macintosh and use 2 fingers. If you use 1 finger, it just moves the cursor around. If you make a gesture with 2 fingers, like left, right, up, down, then we get the gestures firing through the event. So gestures in FireMonkey for Delphi and C++ work on Windows and Macintosh in your applications. In this video, I'm going to show you how to take a FireMonkey application and add actions and gestures to it. We use the FireFlow example for FireMonkey that ships with RAD Studio XE3. This application allows you to take a set of pictures and display them and manipulate them using FireMonkey. So here's the version that just uses the mouse without gestures. And notice that it's displaying pictures in this cover flow model. And we can manipulate and move through the pictures using the trackbar, and we can use the mouse to select specific pictures from the list of images. And that's the example that's built with FireMonkey. It actually showed up in XE2. And now what we're going to do is add actions and gestures to it. Let's add an action list, and we'll add a gesture manager. The first action we're going to add, we're going to call that action first action. And we're going to use that first action to move us to the first image in the list. We'll add a last action, and we're going to use that action to go to the last image in the list. And we'll add an action for the left gesture that'll move us one image to the left. And we'll finally add an action to move to the right in our image list. And for each of these actions, we'll have an onExecute event handler. For the first action, we want to just set the trackbar value to 0. And this takes advantage of an event handler that already is defined inside of the FireFlow application. Setting the trackbar value or changing it will call this event handler trackbar change, which will set the cover index equal to whatever the value of the trackbar is. And set cover index will simply go through the list of pictures and do the animations to move to the next picture or the previous picture or the first or the last picture. And for the last action, set the trackbar value equal to cover flow children count -1. Cover flow is a layout 3D which contains children, which are the images in the flow. And on the last action, we'll set the trackbar value equal to the number of children inside of the cover flow. Since it's zero-based, we'll say cover flow children count -1. The left action will test to see if the trackbar value is greater than 0. And if it is greater than 0, then we can decrement trackbar value. That way we don't go past the first image in the cover flow. For the right action, which we want to move to the next image in the list, we'll simply make sure that the trackbar value is less than the cover flow dot children count -1. And if we're not at the end of the image list, then we can increment the trackbar value. So we've set up our actions. Next, we need to go and associate the gestures with those actions. So we have the gesture manager. All of the images of the cover flow are stored inside of a viewport 3D inside of our FireMonkey HD application. So we'll scroll down and set the touch property and set its gesture manager. Then we'll look at the standard gestures. They'll say for the left gesture, we want to take that left action. For the right gesture, right action, and we'll scroll down and say chevron left. We'll make that go to the first, and chevron right go to the last. Now we can run our application, pick the picture folder, and again the mouse still works, and moving the trackbar still works. We can also use gestures now. So I'm moving the mouse while holding the left mouse button, and moving to the right, moving to the left. We'll do a chevron right, moves to the last image. Chevron left moves to the first. So that's how easy it is to add gestures and actions to an existing FireMonkey application in XE3 using both Delphi and C++ Builder and FireMonkey 2. 4 event handlers that hook into already existing code, taking advantage of the fact that I've got my trackbar change event handler, which then sets the cover index appropriately. In FireMonkey 1, material was a property of the 3D shape components. The new material system is based only on shaders and allows an unlimited variation of lighting and materials in one application that can be applied to all the 3D objects through the use of a T material source object that you can use and share among objects. Let's take a look at the new materials and material source components for 3D objects in RAD Studio XE3. We'll say File, New, FireMonkey Desktop Application, Delphi or C++. Build a 3D FireMonkey application. You can see these new material sources: T-Color material source, T-Texture material source, and T-Light material source. These are all part of the new FMX.materials unit. So if we put a shape down, for example, a T-sphere, and make it a little larger, and we look and see now we've got a material source. In FireMonkey 1, there was materials built into each of the 3D shapes. Now we can just put down a material source. So for example, put a color material source into our application. And then we can set the color, for example, purple, and then go to the 3D sphere and set its material source. And now we have a purple sphere. We can add another material source, make that material source a different color, royal blue, go to the sphere, and choose now the color material source 2. We have a royal blue sphere. Now, using these textures is a new enhancement and improvement in FireMonkey 2. This class, the T-Texture class, uses GPU memory to store real data. We also have a T-Light material source. The surface of a FireMonkey 3D object is defined by its material. FireMonkey 3D materials are based on shaders. This allows an unlimited variation of lighting and materials in one application. So these different 3D shapes, for example, the sphere and the cone, can share a material source. So we can have different material sources and associate them with all our different 3D shapes. And also set a texture. Choose a bitmap for the texture, either to a place where we have picture or texture. And then we can associate, using the material source, that texture material source, and take these penguins and wrap them around the sphere. Extruded objects like a T rectangle 3D has three material sources. The main material source for the surface, the shaft material source, and the back. We can assign different material sources of different types to each of those. So for example, back here we've got our penguins. On the shaft we've got the royal blue, and on the front we've got purple. Now let's take a look at T-Light material source. T-Light material source allows you to set colors for both the ambient light, the diffuse light, and the emissive light. Emissive color determines whether a surface emits its own light. So for example, let's set the emissive color, instead of null, we'll set it to spring green. And then we'll associate with this cone the light material source. And now that cone emits its own color. A diffuse color only interacts directly with light, including the angle of incidence. With no light, it has no effect. And the ambient color is meant to provide a base color to surfaces so they may be seen. In the real world, light is reflected from many directions onto a surface. But in a 3D scene, it would be difficult to define all that light. So ambient color is activated by any light in the space. If you don't have a light, then it has no effect.
And so we'll say File, New, Other. There's three choices. I could build a REST DataSnap server, which will use the RESTful Web Service Protocol. I can build just a DataSnap server application, and I can also use the Web Broker HTTP protocol to build a DataSnap application. I'll build a DataSnap server on its own. We have the choices in the wizard, or we could build one from scratch. The components are also in the tool palette. I'll build a VCL application. We want to support TCP. We could choose the other protocols, HTTP and HTTPS. Do we want authentication authorization? Do we want to use any filters like encryption compression on the JSON packets that are sent back and forth between client and server? Do I want to generate JavaScript files for maybe I've got a browser-based application I want to build that talks to my DataSnap server? And do I want to hook in code that will allow us to build the mobile connectors? What mobile connectors are is the ability to have a DataSnap server in Delphi or C++ and generate the proxy information, the code that will allow you to call from mobile clients into the DataSnap server and to parse the JSON packets and to create the packets to make method calls back to the server. And we have mobile connector support for C# for Windows Phone, for Objective-C for iOS, for Java on Android, and Java on BlackBerry. So you have all those choices in the wizard. Let's just keep it simple and build a simple application. I can choose TCP port, and if I add HTTP, it would ask that. I can make sure that port is not taken. You can put whatever port you want in there. And I'm going to have a server module, so I'm going to put some database operations inside of my DataSnap server. If it was just methods, I'd choose T-component. If it was just database access but no kind of server, the server module gives me lifetime support for everything that's in the connection. For example, when a client connects and goes away, then it goes away, or when the conversation is still going on, keep it together, or do server-side control of the life cycle of each connection. So I'll choose the server module, which gives me total control. And ultimately, it all boils down to three components. The DataSnap server component, which lets me decide if the DataSnap server is going to start automatically, or maybe you want to have your DataSnap server run at midnight for like 10 minutes, for example, with a timer. And it has some events, for example, to keep track of who's connecting, when they connect, disconnect. You might log information. If an error occurs, you might log information through these event handlers. We have the DSS server class, and the DSS server class is where we specify the lifecycle. The choices are invocation. When a client connects to the DataSnap server, it calls methods, does an operation, and then when that operation is done, it shuts down the connection to the client. Session means as long as the DataSnap client is connected to the DataSnap server, it'll keep a separate thread running for that connection. It'll keep it going until the client says goodbye, and then that session shuts down. Or I could decide to manage the connections myself on the server by setting lifecycle to server. I'll use session management here. And then finally, there's this transport, and the transport, there's one for TCP, one for HTTP and HTTPS. Now, server methods has a couple things. In the public area, you can specify any methods that you want to provide in your DataSnap server. And then in my main unit, that's just the user interface of my DataSnap server. So I'll put a tPanel down here, and I'll just say this is my Delphi DataSnap server. And then in the other thing in the server methods unit, which will be managed, I can put some database operations. So let's put a SQL connection. Let's use DB Express this, and we'll go, and I already have an employee connection, and then we'll go and put a SQL query and connect it up to the SQL connection, and then put a SQL select statement. So we'll say select star from customer. And then the last thing is we need to add a dataset provider. And the dataset provider is going to provide to any clients, it'll give us the data and metadata. So we're going to connect it to the dataset, which is the SQL query. And we'll save all of this. Let's now run this DataSnap server. And the first time you run it, you'll get this Windows firewall warning that says, this application called PDT server isn't known, and it wants to access a port. So do we want to allow it? And we can allow it. And so the next time we start it, we'll just let it run. Let's go back now into the project group, and we're going to add a new project. We'll add a FireMonkey client. We'll do an HD FireMonkey application. Now, to connect to our DataSnap server, we use the same DB Express framework. So we'll put a SQL connection component down. In this case, we'll use the DataSnap driver, and that DataSnap driver, look at its parameters, it's talking through port 211. Since I want my FireMonkey client application to work on Windows and Macintosh, I'm going to need to put the host IP address here of my server, my DataSnap server. And so I'll take the address of the machine where my DataSnap server is going to be running, which is the IP address of my Windows virtual machine. And I will paste that in here instead of localhost. I will put down a DS provider connection component, and it will go through the SQL connection. And the other property I have to set is the server class name. The server class name comes from over here, and it's called server methods 1 is the name of the server class that is for the server methods, which also contains our database operations. So we'll put the server class name T server methods 1, and then we'll try to connect. And if everything is okay, I've connected my client to the DataSnap server, which is over there. The other thing I need to do is I need to generate the interfaces for whatever is on the DataSnap server side. And I can do that by selecting the SQL connection component, right mouse click, choose from the menu item, generate DataSnap client classes, and it generates the interfaces for all of my methods, including how to connect from the client to the server, how to call methods on the server, and we'll save all of this now. So the other thing I need to do is use the unit that was just generated, that proxy unit that was generated from the interfaces, which was called Unit 4. And I'll put down now the FireMonkey grid from TMS. So I need to put a client data set down, and the client data set is going to talk through the remote server, which is my DS provider connection, which talks through the SQL connection to get to DataSnap. And then from that, I can get the provider name, because since my DataSnap server is running and I just connected to it, it can query the interfaces and find, I might have multiple dataset providers over on my DataSnap server side. And then I can bind, by bringing up the live binding designer, I can bind the client. Well, let's activate the client dataset first so we can get the metadata and data. Here it is. Notice it just showed up in the visual designer. And I can say, let's connect the client data set to the grid. And now I've got data live in my client. Let's run this client on Windows. And again, this client is talking to my DataSnap server, which is this thing that's running over here on Windows. And I've got data, and I could put a navigator and other things down. Here's the FireMonkey grid from TMS software. I can also add another platform. Let's run this on OS 10 to show that the grid and also the DataSnap client technology works on Windows and Macintosh. This is the FireMonkey grid from TMS. Before I deploy, I need to add one other file into the deployment list. It's a feature file, which is the Midas library, which will give us the support for the client dataset. So I add that to the files to be deployed to my Macintosh. And then I'll just run, and it will compile an OS 10 version of that client using live bindings, using the TMS FireMonkey grid, and then it will deploy it through the IDE. I have my platform assistant server running on the Macintosh, and I can run the client over on the Macintosh using the TMS FireMonkey grid. And again, here's the TMS grid running in a DataSnap client on Macintosh using the Macintosh style.
In FireMonkey 1, there was the T-Platform abstract class where you could get certain platform information. This was good as a starting point, but we now have new PCs, tablets, touch, multi-touch systems, and of course the future of smartphones and tablets and these other kinds of devices. So in FireMonkey 2, we have new platform services support that's based on interfaces, which enables you to get and query information about what services are provided on the platform your application is running on. It also enables you to build custom implementations of certain services if you have special platforms you need to support. Here is the fmx.platform documentation that lists some of the interfaces that are now available that you can use. For example, for seeing if there's a clipboard service or a virtual keyboard service. There's also the source code for fmx.platform, which defines these different interfaces. So for example, the ifmx application service and what interfaces it provides. There's the base class, which is T-Platform Services, which has two functions in particular: supports platform service that takes an interface as a GUID and returns true if that service is available. There's a second form of the supports platform service where you can pass it the GUID of the service interface, and you can also get an output interface of that service so you can use it. And again, it returns true if the service is available. And I have an example application here. It just has a button and a memo field. And what I do on the click handler is I get the RTTI context and I iterate through a set of the services that are available, and I see if it can find that service at runtime. And if it's assigned a value, then I'll output the name of the service, the GUID of the service, and the service interface itself. And if it's not available, then I'll just output the service and its name. And I use an X for not available when it returns false, and an O if it's available on this call, which is T-Platform Services, whatever the current platform I'm running on is, and check to see is there support for that platform service on the machine I'm running on. I have the structure up here. It's a record array which has the name of the service, so fmx.platform.ifmx application service, and then a string human readable form name for the name of the service. And I do that for each of the services. A couple of the services, Windows service, window border service, are in the form unit. The timer service is in the types unit, and the menu service is in the menus unit. The rest are in fmx.platform. So different interfaces, for example, if you're running on a device, or if it supports drag and drop, or if it supports a menu. Of course, we know that devices like iPhone and iPad don't have a mouse, and they won't have a menu service. So you can use that. Windows has a virtual keyboard service. Macintosh doesn't. I'll show an example here in a moment of how to use the virtual keyboard service. So let's just run this application on Windows and see what the output is. And so it says here that we have all of the services are available, the ones with O's, except for the device service. the hide app service and the style high-res service. That's there in case you have a Macintosh Retina display, for example. Then let's go and run this on the Macintosh. And over on the Macintosh, we'll get output for different services that are available on, in my case, on Mac OS X Lion. And then running the application, it'll output the services and show that I have all the services available on Mac except the device service and the virtual keyboard service. But this style high-res service is available for those other kinds of displays. So here's an example that uses the virtual keyboard interface. I've got an edit box and a button, and we'll look at the code behind. I test to see if the current platform supports the virtual keyboard service, and if it does, I'm going to return that interface for the service into this variable KBD service, which is of type virtual keyboard service. And then I will set the focus to the edit box, and I'll use that variable and say show virtual keyboard for my form. And if the virtual keyboard service is not available, I'll simply output into the edit box no virtual keyboard service found. So let's run this on Windows and see what happens. So here's the virtual keyboard, and I can type on the keyboard with the mouse or hit keys on the regular keyboard. And then if I run this on Macintosh OS X, and then over on the Macintosh, when I click the button, it'll just put no virtual keyboard service found. And that's a quick look at the new platform services support that's been added to FireMonkey 2 in RAD Studio XE3.
All right. Thanks, David.
You're welcome. And everyone, Anders, I'm going to take control as presenter. One more demo to show. So let's see, change presenter, David I. Okay, so I'm on a Samsung Slate, and I have two more examples that I've written, and they have to do with getting at the sensor information for the sensors that are available on a machine. And I showed devices earlier, and you can use the sensor management system in both VCL and FireMonkey applications. So this first project is a VCL application. It looks like a VCL application. And underneath the covers, I use the sensor manager, and I'm using the system.sensors unit. I think it was Darren on Tuesday talked about how some refactoring was done when some capabilities are platform agnostic, meaning VCL, or framework agnostic, sorry, meaning VCL or FireMonkey. Then R&D has put the interfaces and the implementations in system. And then if there's something specific to VCL or FireMonkey, then you'll see it in VCL dot or FMX dot in those units. So in this VCL application and in FireMonkey, similar code, I use the T-Sensor Manager class and the current manager, because you can also install your own sensor managers if you want. And I'll set the active property to true. So I'm going to activate sensor management, and then I'm going to use the sensor manager class and for the sensor manager that's currently registered, and I'm going to get the count of the number of sensors that are found. And then I'm going to iterate through the number of sensors down here, and I'm going to output the sensor name and the sensor category by using getEnumName. That's defined in system.typeinfo. And then I pass it the sensor category and the ordinal of the sensor category, the ID that's coming back. And so let's run that in VCL, just to show that you can, there's a bunch of things that were put in XE3 that work, again, when they're framework agnostic, work in VCL, like live bindings, quick bindings, all of that, and in the case of sensors. So here on my Samsung Slate, it says, yeah, I've got device orientation, because Samsung Slate is a tablet. You can turn it horizontal and vertical. We've got the three-axis accelerometer, magnetometer, and inclinometer. Ambient light sensor, because if you take this tablet outside, it'll sense the ambient light and do things automatically if you want with the brightness. And I have a location sensor. Actually, I'm using GeoSense. You can download it, geosenseforwindows.com. It's an implementation using TCP/IP and known access points to give you an approximate location. So it's finding a location category, light category, and so on. And then let's go and activate the FireMonkey version, which is the same basic code. I activate the sensor manager, and then I get the number of sensors and I output them. And again, this is using framework agnostic part of system.sensors. I think I put it up there for this case. Yep. So we'll just run this in FireMonkey, and it'll just output the same thing. And if I had my Macintosh, if I would get sensors, whatever sensors were over the Mac. And I think on my Mac, since I'm on the slate here, I'm not connected to my Mac. There I had the location sensor and also a light sensor for the Macintosh screen. So that's just a quick look at sensor managers and sensor management. And again, the fact that in some cases, some of the new things in XE3 have been refactored down into the system unit name scope, and other things are in the platform-specific name scopes.
Let's see. The first one here is, are there plans for a live screen activity capture so that we can make our own demo productions just like Camtasia?
So the R&D is looking at that. Darren was asked this question as well on Tuesday, and what he said was for this first release of video capture, video playing, the focus was on doing high-resolution video playing with high performance, and so there wasn't time spent yet on full video capture, but they did the frame grabbing, and that's what's in there now, but it's definitely on the roadmap.
Does the media player support the new higher resolution Apple screen displays?
It supports playing high-definition video, so if you play a high-definition video on a Retina display, it'll be a high-definition media control playing in that area of the space.
Can you use the same two-finger gestures on a Windows machine on a machine with a multi-touch capable trackpad?
Warren, as long as it's the correct two-finger gesture, which is the peace sign or victory sign, depending on... No. I tried it on my Samsung Slate, which is multi-touch, and one finger worked, two fingers worked. So the answer is yes.
Is there a visual list of the standard gestures?
Visual list, probably in the help, there's probably a screen... You know, when you're in the IDE, you see the visual gesture to the left of, well, a line drawing representation of the visual gesture next to the left of the checkbox of the object inspector. So whether it's a V or a chevron or circle or double curly Q or whatever, you'll see a representation of each of them in the object inspector to the left of the checkbox, and then to the right is where you can hook an action to a gesture.
How can I register a new video codec?
That's done through register. It's T video register codec. If you go into the fmx.media .win or fmx.media.mac units, you'll see at the end in the initialization section, you'll see how we register the fact that there are different codecs that you want to use. I blogged about that as well, but look at that code. Look at the code if you have the source code, and if you have XE3, not trial or not starter. Look at fmx.media.mac and fmx.media.win at the end, and then you can go inside the code to see how it does it.
Can you still define your own gestures?
In VCL, yes, you can define custom gestures. In XE3 for FireMonkey right now, we support the standard gestures and the interactive gestures, but that's on the custom gestures on the roadmap.